Yeah, so this is like a quiz. So I expect us to participate. So please unmute your mic, answer, challenge your mind. Most of the things we've already covered. So it's just like, let's say, a reminder of what we've been doing. Yeah. So we'll start with the first one. So which of the following techniques is commonly used to handle missing data in datasets? And also don't Google, please. Try to just answer, like compare feature scaling, cross, but then come up with the right answer. Hello guys, I can't be talking alone. Yo, I want to see if you've been learning. So which one is used to handle missing data? Or I start calling names.
Can we say cross validation?
And why do you think it's cross validation?
I don't know, I'll explain it.
So I know we've already encountered cross validation. And if you can remember, we mostly use it when we want to we said we can split data into train, test, and validation set. But then we want to okay, we want to train our data in all aspects. Like we're taking the training data, then we're splitting it into several, let's say, 5 chunks. So we are going to train on 4 chunks, test on the fifth chunk, then do that again until we have already trained and tested on the whole data set. So basically that's cross validation. So the for this question, the technique that's commonly used to handle missing data in data set, it's imputation in our situation. So sometimes you'll find yourself dealing with data that is not complete. So it depends with the situation. So sometimes you might just remove the data that has missing values. So if you realize like you have like, let's say we just have like 10,000 rows and around 50 rows have missing values, you can remove 50 rows is not much compared to 10,000 depending on the data. But let's say you have 10,000 rows and around 70% of the data has some missing values. So you can't just remove everything, you remain with 30% of the data. So sometimes you'll need to check your data set, see what really suits it. So some method include maybe just removing the data set that has missing value. For some cases, you can find yourself imputating. If it's a numeric value, let's say it's an age, you can just maybe fill the missing age with maybe the mean age or maybe the mod, depending on the situation. Sometimes you can find yourself, sometimes you can, some columns can tell you, let's say we have teacher, teacher column and student column. So if teacher is, if there's no teacher, there's no student, they are correlated. So you'll find yourself trying to see this column is correlated to this one. So if this is true, then this missing value should be this, depending on the situation. Yeah, so we have several techniques for handling missing data sets. Any question? Are we together? I don't feel the energy. Come on, we've gone through all these parts. Maybe we didn't exactly handle missing data, but we've interacted with pandas, we've interacted with NumPy. Those are the, especially pandas. It's the library that we're going to use for most of this. You know, imputations, filling, dropping columns, dropping rows. So we're not like entirely blank. Okay, guys, are we together? Linda, are we together? Okay, now I think I'm talking alone, guys. Should you continue the quiz or should I stop there? We're learning. Tamia, are we together?
Yes.
Okay, so you can proceed to the next quiz. Don't you guys? I don't want to speak alone. It's in a collaborative session, so let's learn together. So, what is the main purpose of feature scaling in machine learning? So, we need to understand first what's feature scaling. Anybody? You can still guess. No correct or wrong answer for now until we find the correct answer. So, what is feature scaling? What is a feature? I think I'll start there. What are features? We've talked about this though. What are features?
If I will guess from the general term, feature is like characteristics.
Yeah, characteristics. So we said we have features and a label. So features tell maybe characteristics of the label, right? So we said we have several things we can do to our features. Sometimes we need to do several what do I call them? Editing or something like make them easy for a machine to learn from. There's a way a machine understands data, then there's a way we understand data. So you have to put it in a way that a machine understands, right? So feature scaling mostly comes when you want to standardize your features. Maybe you have, for example, let's still use the housing example because it covers a lot of a wide range of explanations. So it's like I want to standardize my features so that there's no feature that will stand out too much,
Will
and
I,
there's no feature.
will I answer
Mhm.
your question about what feature scaling is?
Yeah, yeah.
Okay, so it's a it's a pre-processing technique. So that's
Mhm.
you um transform like features to a common scale. So it prevents features with larger values from unfairly dominating the model, so
Mhm.
that uh, um, they won't be like no, they won't be proportion in the ranges. So it
Yeah,
will affect the impact of the model's outcomes. So that the model can perform like well. You need to ensure these are common scale.
yeah.
So
That's actually a perfect explanation because we are teaching the model on data. So what garbage in, garbage out. So when you tell the model these features are predominant, it's going to take them and assume these are important features. Then it's going to ignore maybe the lesser important features. So yeah, standardization does that. Thank you. That's nice. Can proceed. Which encoding method is most suitable for converting categorical? We mentioned this one, guys. Which encoding method is most suitable for converting categorical variables with no ordinal relationship? Ignore the wording into numerical form. So we have a categorical feature. A machine is not going to read. bedroom, sitting room, kitchen. It's not going to read those words. So we have to convert it into a way that it understands. So, and why are we doing encoding? Let's talk about encoding. And which one is it in our case? And also, as you can observe, this the answers are like interlinked, because you can see feature scaling in the answer. So, you know, it can first be confusing, but with time you're going to understand this is for training the model, this is for choosing the features, this is for validating it. The more we expose ourselves to the information. Anyway, so question 3: what is encoding and which is the most suitable for categorical values?
Encoding in simple terms means it's the process actually of converting information from one format into another.
Yeah, that's great. So in our case, we are trying to convert categorical variables into numerical. Which one is the most suitable?
I think I'd say one hot encoding because it will work by creating the new binary columns for each category. Like, for example, if I use an example of colors, if there is a column for red, blue, and green, it will give each column one and the other one's zero. So, like, it doesn't make one color more, maybe let me say, more important than the other. It gives a unique
Yeah,
category to each. I think I'd say that.
it's actually the correct answer. Yeah, so it's one hot encoding. It gives numbers to our categorical features. So that's how the machine understands. So any questions so far? K-fold cross validation. As I said, you notice these things keep on repeating themselves. So the more we learn, the more we start differentiating them. So K-fold cross validation helps him. Why do we do K-fold cross validation? Anybody? Why do we do K-fold cross validation?
Performance of a machine.
Yes, louder, please. I think I've already explained cross validation in, I think, the first question. So we said like we are splitting the training data into several chunks. Then we train. We make sure at the end of the day we have trained all the data and tested on all the data. So why are we doing that? Honestly, there's only one obvious answer, guys.
I think it's to prevent overfitting
Yeah,
by testing on the unseen data.
it's preventing overfitting, because we are doing it when we are training the model. So deploying the model, that's already trained model. Saving trained, that's already trained. Feature scaling, that's before training. So yeah, it's preventing overfitting. Okay, so a build up on k-fold cross validation. If k is 5, but we said I want to call it a I want to call it a hyperparameter, but you can set the number of k's. It's not a hyperparameter because it's not for the model. What do I say? Remember, hyperparameter affect how a model trains, how a model learns from the data. But now for k-fold, when we are setting the number of k, we're just setting how many splits do we want our data to. I've already answered that for you guys. So when k is equals to 5, our data is split into
5.
Yeah. So you set the number of k depending on your data set. So don't set like if the data is small, don't set like a large k, because your data is going to, be too small. in the, if I say K30 and my rows are 10,000, that's a lot of splits, you know. And also it slows down the training. So there's a trade-off there. Which of the following is used to search for the best combination of hyperparameters for machine learning model? So we talked about hyperparameters. We say that we are the ones in control of hyperparameters. But now we say, instead of always trying and doing try and error, trying different combination, then training your model, then realizing, no, this is not the right one. There's a way we can make it easier, right? So which one is used to search for the best combination of hyperparameters for a machine learning model? Mm-hmm. You can just start by eliminating the ones that don't fit into that category then now. For example, model deployment. We are training the model, so model deployment is not the answer. So between the B, C, and D, which one is it?
Grid search.
Yeah, grid search. Remember, we had a long discussion about random search and grid search, talking about how they work. So, guys, don't forget what we've learned. I know it's a lot of information, but keep on reminding ourselves. We've already talked about cross validation. We now we understand cross validation. Now we have grid search, and then we have already talked about feature encoding. You see, the answers are just interconnected to help us understand more. Which Python library is primarily used to build machine learning pipelines, combining preprocessing and modeling steps? Mm-hmm. Which one? What is a pipeline? Like the basic definition of a pipeline. What is it?
I would say it's chaining data together to provide a smooth flow.
Yeah, a smooth flow. So, for example, I'll just use the, because we've all done several projects by now. So if you remember the one that we did on linear regression, we had like several steps. The first step, maybe we import linear regression, we feed our model, we train our model, we test. So some steps are procedural. You can't test your model maybe before you train your model and so forth. So sometimes if you can automate that work by creating a maybe a small pipeline that will help you, you know, just feed the model to the pipeline. Then it's feed the data into the pipeline. Then everything is going to happen. It's going to split, test it, do this, do this, do this. So yeah, it's like automating a process. So we talked about Python libraries. Python library. So the most common one for machine learning is scikit-learn. So just because you've said it's for building learning pipelines and maybe you've used it for just import linear regression, import logistics, doesn't mean it can't create, mostly for machine learning, you're going to use scikit-learn. For your most, I think even for 99% of your machine learning projects. Yeah, so it's scikit-learn. Is Flask even a Python library?
Oh, no.
And what does it do? It's for web frameworks and so on. So, in our context, building machine learning, web framework, seeing the difference. Mostly, pandas is for data manipulation. That one we know. What does Fast API do? So, as you all know, like Python is a wide programming language that is used in many applications, from web development, creating APIs, data science, data analysis, a lot of uses. So we have like a lot of Python libraries that exist. So don't worry about cramming all the libraries. They just, the more you use it, the more maybe you'll find yourself one time using other libraries that we haven't mentioned. But the ones that we've already mentioned, those are the most crucial for data, ML, and the planning. So you might find yourself doing importing more libraries. So yeah, because Python is full of libraries and a lot of functionalities too. So which file format is commonly used to save trained model, trained machine learning model for later use or for deployment? This one is so obvious. Which one?
D.
Come up again.
D.csv.
Y.csv. Y.csv. I think CSV stands for comma separated something, but mostly CSV, you'll find yourself using it for data. For example, some CSV files can be opened using Excel. Like they just like read like Excel. So personally, I it's like when you save an image at as.jpg or .jpg. I usually don't see the difference personally, but you're saving an image. So Excel, the second one, XLSX and CSV, they are more related. So mostly for storing data in tabular form. JSON stores data like Python dictionary. So you remember when we talked about Python dictionary, we said it has like key value pairs. We have key, we have value. So keys are unique, but values can be anything. They don't have to be unique. You can even have values in terms of lists and so forth. So JSON file format stores data in form of Python dictionary. So when you understand Python dictionary, you'll understand JSON, because it is even applicable in many situations, not even in data science. So the most obvious one is .pkl. It's like a pickle file. I think it's called a pickle file. Yeah. So, any question? Okay, proceed. Flask and Fast API are mainly used for. I think we've already answered this question, but anyway, let's see if you're concentrating. Flask and Fast API are mainly used for.
Web deployment of machine learning models.
Yeah, that's correct. So, what is the primary advantage of using pipelines in machine learning workflows? I know we haven't used like a pipeline per se, but we already understand the process. We can automate that process, make it easier to train models without having to repeat the coding and so on. So, what would be the advantage of doing such a thing? Why would you want to create a pipeline and automate that process or make it easier?
They allow for a streamlined process combining pre-processing and modeling steps.
Yeah, so streamline process, like giving a procedure, makes work easier. Yeah, so that's all for our quiz one. I have another quiz if you guys are ready. You can see we've learned a lot. So another quiz or we head direct to NLP.
We could do another quiz.
We can do another one. Okay. I think it's just right here. So this is for neural networks mostly. Which of the following best describes an artificial neural network? This here was from our previous class, guys, so it's still fresh in our head. What is an artificial neural network?
B.
Yeah, connection of interconnected nodes designed to mimic the human brain's neuron activity. What is the primary function of activation functions? Talked about those. Why do we use activation functions? We still introduced this in our previous class. Yes. Yes.
To introduce non-linearity into the model.
Yeah, to introduce nonlinearity. So, in an artificial neural network architecture, what is the main purpose of hidden layers?
They they perform feature extraction and complex transformation of the input data.
Yeah. So, when you're training your deep learning network, most of the time, hidden layers, this concept applies to deep learning. You're not going to do this feature thingies. The model is going to learn for itself. You just need to feed the data in a way that the model understands, then just leave it to the model. So convolutional neural networks used for, come on guys.
Computer vision tasks.
Yeah. So which technique is typically used to minimize the loss function in neural networks? So in neural networks, what do we use? We're minimizing the loss function. We say that's the goal. We don't want our model to overfit, but we also want, we don't want it to overfit, but we want to have the least loss. Like we want it to perform perfectly, to be as accurate as possible. So what do we do? What do we do?
Can I try?
Yes, please.
C.
Yeah, it's gradient descent. So we talked about gradient descent. We said our model will just start somewhere, then start minimizing the error. So let's say the first round it just trains and tests and realizes I'm so far from the being accurate. So it starts learning from there, improving until we completely minimize the error. It's really, really hard to find a 100% accurate model unless it is overfitting. But then, 90, 95, 90, it's not bad. That's a good score. Even sometimes 70, 80. Don't always focus on the 90. The model can overfit. So we did this assignment when training an artificial neural network on a mixed data set. What is the primary task being solved? We'll realize who didn't do assignment, who didn't submit. Mhm.
Handwritten.
Yeah, we're trying to classify handwritten digits. Recurrent uh, neural networks are best suited for which type of data? We talked about different types of neural networks. So where do we use recurrent neural networks?
Sequential data.
Yeah, it's accurate. Which of your following is commonly used metric to evaluate the performance of a classification artificial neural network? Classification.
C.
Yeah, a confusion matrix. In the context of deep learning, TensorFlow and Keras are primarily used for
B.
building and training neural network models. That's impressive, guys. That's all for the quizzes. At least we've reminded ourselves about what we learned last week and also some concepts that we had learned earlier on. Now, with that, now we can proceed to our today's lesson, which will be natural language processing. We learn about transformers, but we are going to learn natural language processing first. So, what is natural language processing? Just guess in your own definition. What do you think it is?
I would say that it is the model understanding and giving output in a way that is natural.
Yeah, it's like the model is understanding your language. The way we just speak, the way we're just having a conversation, it's just flowing. So it's like a model is understanding that aspect. So we've interacted with natural language processing in a lot of instances. We use AI every day, ChatGPT, DeepSeek. Nowadays we have a lot of those. We also have a situation where I just go to, maybe you're trying to search for something, you don't feel like typing, so you're like, you just what is the most, how is machine learning, you just like speaking, then the machine is interpreting and then giving you answers. We have several situations where you can have literal conversations with machines. They seem to understand you. And also the way even these LLMs work, sometimes you can just wonder, am I even talking to somebody? Because it feels like they already understand what you mean. They get you, they answer in a way that you understand well, and so on. So basically, natural language processing is how computers understand, interpret, and generate human language. So it's a mix of linguistics, computer science, and machine learnings. machine learning, and it helps computers to talk to us and also understand us. So that's just an overview. So today we are going to define NLP. I'm going to use NLP for natural language processing. And also we're going to explain key tasks such as tokenization, POS tagging, named entity recognition, language modeling. Don't worry if the words are new, that's what we are going to learn. We're going to describe the evolution of natural language processing. We're going to explain the architecture of transformer models. We're going to use libraries such as Spacey and Hugging Face transformers. So Hugging Face it's just like a place or a site where you can find a lot of open source pre-trained models. So sometimes you just want to ah deep learning, it needs a lot of data. So if you're even training like a deep learning model from scratch, you will need a lot of data because neural networks excel on data. The more the data, the better it is. So we have a lot of models in Hugging Face. Let me put up the presentation mode. We have a lot of models in Hugging Face that you can just, they're open source, you can just leverage them and use their architecture to fine tune your data and so on. So you can even go to the page. It's just an open source, so just explore, see what people are doing there, see how many, what models are there, how you can use them and so on. And also we're going to apply the concepts to an assignment. So we said it's an intersection of linguistics, AI, and computer science, because language, linguistics, AI, machine learning. Yeah. Artificial intelligence, machine learning, etc., and computer science. So it focuses on enabling computers to understand, interpret, and generate human language in ways that are both meaningful and useful. So NLP powers many of tools we use today. We've already talked about voice assistant, translation, spam filters, chatbots. And the list is endless because nowadays we are so used to talking to the computer, we don't realize it's NLP working. We're so used to talking to the computers and so on. So you can say NLP is made up of two subfields: natural language understanding, which focuses on semantic analysis. It's like it's trying to understand words. This means this is connected to this. You see, for us, language comes so naturally. But to computers, it's not that natural. We have to train the computer. We have to say, I'm feeling hungry. It's connected with I'm eating. I just had my lunch. I just had a meal. We have to tell the computer those words are connected, you know. So we have to make the computer understand that. And also we have natural language generation. So this by it's just as it is generating. So some models focus on understanding natural language, others focus on generating. Sometimes you have models that have both understanding and generating. Applications of NLP: sentiment analysis. We can use NLP to process sentiment. I think I'll just refer to the original example, customer feedback. We want to see, is this a positive or a negative feedback, etc. So you can just run your model in your data and then it's going to tell you how many people just don't feel your product, etc. So sentiment, what do you mean? Is this positive? Is this negative? We want the machine to be able to understand our mood. I'm bored, I'm sad, I'm angry, I'm happy, and so on. Toxicity classification. We can classify several things that maybe are fall into this hostile intent. So for sentiment analysis, we're trying to make a computer understand what is my intent, what is my intention, trying to understand us. So we have several situations where it's on another level. So also we can use NLP to do this. Machine translation. I think it's like 2 months ago or a month ago. I bet it's 2 or 3, where Google launched this system whereby I'll be talking. Then maybe I'm talking to somebody who does not speak my language. So I may be talking in English, then somebody who's receiving the language is, let's say, which person? Let's say they speak Spanish, they don't know anything about English. So it is like a live translation. So as I speak, they're getting their own, the word is being translated into Spanish immediately, and they are receiving, and then they can talk back and so on. So nowadays we have several advancements in this field whereby there's a lot of translation. There's a day I was using an app where, like, I can just text in my language in English, then somebody using another language just text in their language. Then it's going to translate immediately to English, then it's going to translate immediately to their language and so on. So we have this a lot. Sometimes you might want to create an application that is targeting, let's say, farmers in a specific place. But then you realize these farmers don't even understand technology that much, leave alone English and everything. So you want to make it as easy as possible for them to use. So you can put maybe a translation into their language, make it easier to communicate, make it easier to use your application and so on. So remember also, in as much as we have the AI and so on, we're still solving problems, we're still using this to solve problems, the problems that we have. Even for these big companies, OpenAI, they have solved our problems. Now you don't even have to go to the web anymore and research over 10 pages or on an information. You just tell AI, just research for me, give me the links. You're going to the direct to the page. So you're still solving a problem here. So yeah, machine translation, name entity recognition. So this aims to extract entities in a piece of text into predefined categories such as personal names, organization, location, etc. So you can use even NLP in, let's say you have a data entry. If somebody does some data entry, you can use this named entity recognition to categorize those things, and so on. And many, many other uses. Spam detection, classifying email, grammatical error correction. So as I said, we had AI from the go. Like we had we are already used to using machines. We don't realize that we have some model embedded into our systems, our devices, like autocorrect. It's predicting our words, trying to get it correct and so on, etc. Topic modeling, text generation. This is what we are at. Nowadays, even when you're writing, even the slightest, you just, hello, please write for me, please do this for me. You get your text well generated. It's even better than what you could have come up with. Information retrieval. I think I have already explained. Sometimes you just tell ChatGPT, I want information on this and this, and give me the sources. It's going to give you this. It's going to retrieve that information for you. Summarization. You want a document to be summarized. There's a way you want it to be written, etc. Answering questions, etc. These are some of the examples. It has a lot of uses, and we use it every day. Yeah. So NLP pipeline, how does it work? Because we have raw data. Our data is text. It could be a paragraph, could be anything. It's words, texts, etc. Also for some cases could be audio and so on. So let's say, for example, we have raw text, mm, anything from tweet, anything, and just any text. So we do pre-processing. As we said, pre-processing is a very important aspect of what we do to data before training our model. We have to pre-process our data. In any situation you find yourself trying to use machine learning or deep learning, pre-processing is important. So cleaning the text, removing unnecessary elements, etc., feature extraction. Then we're trying to train our model. Then our model, depending on what you want it to do. Do you want it to analyze the sentiment? Do you want it to generate new text? Do you want it to classify something? etc. So this is the NLP workflow. It looks familiar with the ML workflow. It's almost the same workflow. Maybe this time around the data can be different now. So natural language processing pipeline. So sentence segmentation. So what does this preprocessing entail? We have, let's say we have a full sentence. That sentence is going to be segmented into chunks. I think when I call it chunks and it's a sentence, I think paragraph, when I say chunks and paragraph, that's going. Okay, let's say we're going to segment into, yeah, let me call it chunks. So you have a paragraph. We break this paragraph into sentences. Then we tokenize. What is tokenization? It's like we are splitting words. So we sometimes we have character tokenization or word tokenization, but word tokenization makes more sense because let's say I say I love chapati. So tokenization is I, that's an individual word. Love, that's an individual word. Chapati. So it's like it's splitting into words, you know. It's like it's like it's stripping your sentence. Yeah. So we have the next part, right? Predicting parts of speech. Mm, I have an example. Not example, better illustration for tokenization. And why it's important, I'm still here. So let's say we have situation, we have, let's say play. I like playing. Let's say I said I like playing. I like, oh god. I hope we can read. I hope we can read that. So I is an individual word. I like. So in our tokenization station, it can even say play. Then split into in. So it will gives a room for, let's say I say eating. It's going to handle this as individual token, which means it's easy when I'm saying eating, reading, our machine is able to connect the dots, and so on. I hope you're together. Predicting parts of speech. If it's a noun, what does I? We've already split. What does I mean? Like, is it a noun? Is it a verb? Etc. Play, is it a verb? It's like our machine is trying to understand this word. Where does it fall? Then lemmatization, converting the words to their root form. I think this part plays a role there. It's like you're stripping the word. Let's say you have I think this one explains lemmatization even better. We have playing, but the word there is play. Eating, but the word is eat. You know, so it could be ate, eaten, eating. It can be a lot. But now we have the base word, the base one. Remember when we were learning English for the first time in primary and all, we have the base word, the root form. Uh-huh. Stop word removal. What is a stop word? These are common words. In a sentence, most likely you're going to find a, the, I, I, the, and uh, this is a book. The common words, because they kind of dominate, they dominate in text context. So we don't want our machine to think that these are important words. No, they are not. Because this, let's say this part is the most important. I like playing. Like playing. But now the I can be in every, you'll find maybe play appears once in maybe in the paragraph, but I is appearing almost 200 times because it's a common word. So remember, we're the one who is teaching, we are the ones training a machine. So machine is going to assume I is very important because it's so common, but that's not the case, you know. So yeah, we remove those words. Dependency passing, we create syntactic tree and understand word relationships. So we understand the connection between eating and hungry, playing and dirty, playing and football, playing and basketball. So like we are trying to connect the dots, like this word is connected to this word is far from this. We have some words that are far from each other, because even in a situation, sometimes you can just get the context of a situation. When people are talking about something, you just need to hear maybe one or two comments, then you realize, they're talking about this. So we know some words are connected, some words are not connected at all. So trying to create that understanding, that relationship. Name entity recognition, this applies for personal information. Conference resolution, resolve pronoun and expressions referring to the same entity. So one thing you have to understand, human language is a very complicated aspect also, because as I said, speech comes naturally to us. Even the way I'm talking, the way I'm changing my tone, and when I'm explaining, when answering questions, it's just so natural. Like it just comes. Some words in, even in our own languages, you can have the same word having different meanings. Just the way you're pronouncing the word is different. But it's fine. The just one word having like three, four meanings, depending on the pronunciation and so on. So these are all important factors to consider in NLP, and we're trying to make a machine try to understand us, try to process words as we process. We're trying to make it come natural for the machine. Yeah, so this is just the pipeline that we use. So any question on this slide? I know it's an intense slide. It has like, it's like summarizing the whole thing into just one page. But any questions? Are we together? Have we understood this slide? Because it's a very important slide, guys. Have we understood it?
Yes.
Okay. So, so get back to that. So this is like the pre-processing pipeline. So we talked about, we have the raw text, the pre-processing part, tokenization, lemmatization, etc. So now we go to the next step, which is picture extraction. This one. So it's a process of converting raw text data into numerical representation that can be understood by machine learning models. So since a ML model can't understand words directly, we must extract meaningful characteristics from the text, like word frequencies, position, or contextual embeddings. So, what are we trying to do? We have done all those things, but still, we still have our raw data. We still have tokenized, lemmatized, etc. But it's still data. Love, play, eat, etc. You know. But now our machine cannot understand that directly. So we have to convert that raw data into numerical representation that the machine learning model can understand. So we can extract meaningful characteristics, e.g., frequencies of words, position, etc. But now with the new technology, transformers, for example, like ChatGPT, it's a transformer model. It tries to create the relationship between words. So it's like it is like seeing through that paragraph and trying to create the relationship between words. It's like trying to understand how words are connected and so on. Also, we have other ways in which you can do feature extraction. So one would be checking how frequent a word appears, where it appears matters also, you know. Weights. We give importance to each word. So we are going to see it's like allocating importance to several words. Like how important is this word? How less important? Of course, you don't expect those simple words to be that important, but then we have those words that don't even appear frequently. I think I'm already explaining this term frequency, inverse document frequency. So normally I would say it's data. So if a word is appearing a lot of times, um even as normally, even for us, you're more likely to pick on that, because it's common. You can see it everywhere. So it's the same for a machine. But now we want our machine to give importance to even the words that appear rarely. You can realize like a word might appear rarely, but it means a lot. Like it's like everything in that context, it is bringing a different perspective. So this term frequency, inverse document frequency, it balances between how often the words appear and how rare the words appear. So it's not only focusing on the most common words, but it's also focusing on the least common words, trying to see. It's like creating a balance, because when you focus on the most common words, you can miss the context. Yeah, so let's get deeper into tokenization, tokenizers. So we have a new term here called bag of words. What is bag of words? What is it? Which is the best example to so I already said tokenization. I think I'll just use this example. I think it's easier. So this is good, is it not? This is bad. This is awesome. So if we are doing word tokenization, we are going to split this is, good. They're all like their own words, even like the punctuations and so on. We're going to also split this one too. This is bad. This is awesome. And okay, so in tokenization, we are going to see how often does each word appear in every sentence. So, for example, in this first sentence, this is appearing only one times. Is appearing two times. Is it not? Two times. good, disappearing once. So we're going, it's okay. Sorry, guys. So as you can see, this matrix, it contains all the words that are here, like everything. This is good, is it not? Bad, awesome. Because this is has already appeared. So yeah, so we are trying to compare. We're trying to see the frequency of these words. So this is the concept of bag of words. Are we together? Then from then we can like allocate like some weights into the words. For example, you can see the words that don't really appear that much are given a higher weight than the most common ones. These are the most common ones, and so on. Yeah. So this is the concept of bag of words. So trying to see, tokenize first, separate each word from the sentence, check its frequency, and then allocate uh, some weights to the words. So are we together?
Yes.
Okay. So also it's also important to understand now this aspect, term frequency, inverse document frequency. We said term frequency, it's we are checking how many times a word is appearing, the frequency of the word. Then we said inverse, it's like the opposite. Now we are checking which words that the words that don't appear frequently. So we've already said this is good, bad, awesome, and so we've already done. Okay, sorry. In our previous slide, we already created this matrix. But now, how does TF-IDF work? So it's almost a similar matrix, but then it's going to allocate some weights on the tokens. And then our inverse document frequency, it's going to create a log. So if you can see, you realize like what does it what happens when we apply log to that word. I think this is a mathematical aspect, but what I'm saying is term frequency, inverse document frequency, what it does, it is checking the most frequent words, but also considering the less frequent words, and applying even more weight to the less frequent words, because sometimes they are contextual, because they are rare. So which means they appear in different contexts. If I'm talking about a situation where just that word is only found in that context, that word is important because it gives context. So I think that's like a summarization of what I'm trying to explain. So any question? So are we together? Hello guys, up to there, are we together?
Yes.
Okay. um I didn't want us to go through the whole NLP because I know it's intense. It's a lot of things we are learning at once. So I think I'll just open room for questions. Like if you have any questions so far, and if you have any concern, are we together? If you're understanding, if you feel like I should repeat a concept and so on. So any question, guys? So just to summarize what we've learned today, we have introduced natural language processing. Then we've said we're trying to make machines understand our language and also be able to speak our language in the way we are speaking, the way now we are speaking, and so on. But now we have our language, which can be in form of text. How do we make the machine learn this language and learn it in a way that it gets the context, it's able to get the sentiment, the intent, etc. So this is just the process. We talked about pre-processing, I talked about tokenization, and yeah, that's what we have. That's the summary of what we've learned today. So the next class we're going to learn more about. I think it's here. We'll learn about embeddings, but I'll send the slides. So if you have time, you can just go through them and see if you understand some aspect, or maybe it will feel more familiar to you. Then learn about feature extraction and also learn more about the models that we use, the current models that we have, you know, etc., and how to train a model using Spacey and natural language toolkit, etc. Then we have a mini project and so on. So by the end of this lesson, we'll understand like a lot on NLPs, be able to understand ChatGPT and stuff. So any question, it doesn't have to be question on the current class. You can just ask if you've encountered any questions along the way. So you guys have told me you're trying to catch up with the classes, with the lessons, with the notes and everything. Do you have any question? So does it mean that we are all okay? Or I'm making an assumption? Are we okay? Up to there? Are we all understanding what's really happening?
I have a question.
Yes, Sharon.
Um, it's not tailored to a specific topic, but it's more of like a general one.
Okay.
By the end of this boot camp,
Mm-hmm.
will we be able to understand, like you've said, in the next lesson, we'll be understanding a bit more on the chat GPT and other AI models. Will we
Mm-hmm.
be able to kind of create our own or understand the process of creating one?
Yeah, I think we have a mini project for NLP. So by the end of this chapter, actually, we'll be able to understand a little bit more about that. But also, some things I want us to understand. We'll understand how ChatGPT works, but then can we create ChatGPT? No. Why is it? Because it's a large language model. It's so expensive to create. We need resources. We need like GPUs. We need data. As I said, these neural networks, they feed on data. So we need data. We need a lot. So I can't say we are going to create our own ChatGPT because that's a large language model, but we can create a small language model, the one that just depended on maybe the files that we have and maybe that uses the resources that we have. But then understanding how ChatGPT works is important because in real world, you're going to use that information in creating several projects. Example, if you're tasked with creating a chatbot, you might need to pull the some let's say you might need to pull some aspects of ChatGPT to your chatbot using an API, depending, or maybe you can take a pre-trained model, then fine tune it using your own data. So in real world application, unless maybe you find yourself in open AI, or maybe these companies that are coming up with this new technology, you, in your own capacity with the machine that you have, you're not able to create a large language model, but then you can leverage that technology to create other stuff like chatbots, text processing, text translation. Maybe you're creating an app and you want to put translation into your app. You need to pull some aspects of these models. So understanding them helps us know how to use them. Have I answered your question?
Yes, yes, you have. Thank you.
Okay. Any other question?
What are large language models? I've seen it on a site called Hugging Face,
Mm-hmm.
where like they are trained.
Mm-hmm.
Yeah, I just wanted to ask about it because I encountered it when I was just researching about it.
So I think an example of, I think we're already using them currently, like ChatGPT. But then, what is a large language model? Interesting. So I can say it's like it's just an AI that maybe understands, generates, or even is able to manipulate your human language. So it can maybe write sentences, answer question, translate text, summarize information. It even having conversations. Even right now, you can have a conversation with ChatGPT and so on. So it's basically it's a model, like ChatGPT is a large language model. But then what makes it a large language model? It's because of the data that it has been trained on. So large language models have been trained on large a lot of data. That's why you sometimes you feel like chat knows everything, right?
Yes.
Because it has been trained with like literally all the data in the world. I will say it knows a lot of information. So training it with that amount of data, and also when you are training that model, remember we talked about parameters and also talked about hyperparameters. So parameters are those things that the model learns, or maybe the things that are in the models. So you'll find like for large language models, they have billions and billions and billions of parameters. So those aspects, I think those aspects are what makes them large language models. So an example would be ChatGPT, DeepSeek, Gemini, we have Cloud, we have Perplexity. Nowadays, I think every day I'm just discovering a new large language model in the market. Yeah, so that's an answer for what is a large language model.
Okay, thank you.
Okay, you're welcome. Any question? And also they are built using neural networks, so it's deep learning still.
Okay.
Mm-hmm. Any other question? Any other question? Even a general question. And also, though you said you found them use in the site, the Hugging Face site. It's a good site. You guys can go look it up. It's called Hugging Face. As I said, it has a lot of pre-trained models. Like they are just open source. So you might open source means it's free, it's accessible. You don't need to pay. You can just use them and so on. So most of your projects, maybe in real world, you can find yourself leveraging such models, the ones that are open source, and maybe trying to give them your data. So we have an aspect that's called fine tuning. Fine tuning is whereby you see already if I have a model that's already, I say pre-trained, it has already, we talked about overfitting, reducing the loss, but also we said we want the model to learn the patterns in the data, not the data itself. We want it to learn the patterns that are present in our data. So let's say even for computer vision, when you have a pre-trained model, it's a model that is able to take images, pre-process them, and so on. So maybe you can find a model in Hugging Face that is pre-trained on a lot of images, but then in your situation, you just have you have your own data. So what you do, you can leverage that model because it has already it has already learned the general pattern of images. So fine tuning is whereby you put your data in the last layer. It's like you're trailing the model. Now I know you've already learned about images, but now focus on my data. Focus on my data. Give me the output according to my data. So you don't have to train the model from scratch, but you can just use those pre-trained model to fine tune with your data set. I don't know if we are together there or any question on that. Okay, I think that's it. I think at the end of I think for our last class, we can have like a session where you guys can just ask general question about data science, concerns about what you're going to do in real world if you want to do it as your career. I'm also putting into consideration for people who say they want to learn data and AI and ML so that they can use it in their respective fields. So if you have those questions regarding real life applications of what you are learning and maybe trying to see where does this knowledge fit in, what are some of the things that I can use, or some situation where I can apply this skill, we can have those that session if you guys are okay. You guys will let me know, and then you can just learn more about beyond the skill, what next. Okay.
Yeah.
Okay, so any other question, guys, before we finish the class? Okay, so if we don't have any questions, today's class, we end it there. So for those who submitted the assignments, I'll get back to you with a feedback and everything before our next class. And with that being said, see you on Thursday, guys. Keep learning.